so I guess we'll start off this way. Does anyone have any questions, any thoughts, anything? What are people thinking here?
Hey, Dom, this is David. It looks like what everyone is posting in the chat isn't showing up in your chat window. I can see 18 people, and Rupesh just typed what I'm typing is not showing on your chat window.
Yeah, exactly. Is my voice? I mean, can you listen to me? This is Rupesh.
Yeah, I can hear your voice.
Okay, so yeah, but I mean, since I can see your window, I can't see what I typed in the chat window.
Well, I'll tell you what, Rupesh, could you act as well, I can see Christina Johnson. I just logged out and re-entered the meeting. So I'm guessing that, let me see if I can see her now. Nope, just me. Well, I'll tell you what, guys.
I see something odd too. I can see 4 participants in my screen, but 7 on yours.
Oh.
Yeah, and I can see 17, so it looks like we all have different numbers.
Yeah, I see 8. I'm going to do this. I'm going to go out and come back in.
Okay, here's what we're going to do. Somebody who's on a phone, your job will be to do one thing: watch the chat window and tell me what people are typing. We're just going to sally forth. So let's start off with who has some questions here.
Can you hear me?
Anyone?
This is Tom. Can you hear me?
I can hear you, Tom.
Well, great. You mentioned something about building a Heloc model. I think that would be a nice place to start, perhaps.
I can handle that, sure. I want to.
And Don, I would love to see the Heloc as well, but I would love to see a demonstration of Angus if we have time.
That I cannot help you with Angus for 2 reasons. One, my license expired, and B, I am not an Angus expert at this point. I was only given access to the tool, and I fumble around with it like the rest of you guys. I am sorry to say I can't help you much with that.
No worries. I'll see what I can make happen this week as well.
So, let's do one other thing. Is everybody, if you're not talking, throw yourself on mute so that we don't we don't hear the background noise.
Professor, this is Rahul. I have a question as well.
Okay.
In the linear regression that we did in 410, we went through some diagnostics on the model. Could we spend some time talking about what kind of diagnostics we can do in the proc logistic and how to interpret some of them?
Sure, we'll do that. I think as we go through it, we'll try to kill 2 birds with 1 stone, and we'll do I'll show you how we can diagnose the model itself. How about that? Are you okay with that?
Sounds good. Thank you.
Okay,
yeah, that
fair
sounds
enough.
Great.
Okay, so how about this? Let's dive into building a Heloc model at this point. Can you guys still see my screen? I'm going to stop sharing and start sharing again and see if I can start sharing. Can you see my mouse moving around?
Yeah.
Yep. Yes.
Okay, so I'm going to stop and see if I start again. What will happen? Can you see my screen now?
No.
Okay, so that's good. Let me try one last time. If I start, I'm going to try to start sharing again. And now let's see if I can see the participants. No, dog nabbit. Oh well.
This is Rupesh. I signed out and came back in. Now I can see all the participants on the participant list.
Okay, well, forget it. We're just gonna build some models here. Okay. Tell you what, let's do. I started off by I have here something that I just started right here. So this is a completely empty program. All I'm doing here is I've got the Heloc data set right there. So if I run this guy, and let's do this in proc print. I'm just going to build a quick and dirty model for you. Okay, so for people who are not new or who are still learning about macros, I've got this macro variable called path. So every time SAS sees this guy right here, ampersand path dot, he's going to know that it's this directory. So that's and then the nice thing is if I move this program somewhere else, all I really need to do is update this guy here, and it just changes everywhere else. So what I'm doing here is really, I'm doing a really, let me do this. I'm going to try to not confuse people and get too clever. Oops, what did I just do? I'm about to do something. I'm going to try to keep this really, really simple here. So now I have this thing, it's called linear regression, or my library is going to be called LR. I can call it anything I want. So what happens is the path right here is going to be the path that is pointing to where my data is. And then I've got this libname statement. So this is, let me run this stuff here. And now, every time SAS sees in file with an ampersand and a dot, he knows that I'm talking about linear regression and Heloc. So let's run this thing and run a proc contents and a proc print. There they go. So you can see that I have 4,730 observations. These are my variables, and this is my model right here, or this is my data sets, the first 10 records. So how would I build a model if I was going to do this in a real world situation? Well, the first thing I would do is a best practice for me is I make a copy of my data set. Why? Because in a real world, you might screw your data set up. So if you make a copy of it, if you do something crazy, you can always get your data back. So I'm going to create a data file, and it's going to be called temp file. Okay, now what am I doing here? I'm creating a macro variable called temp file, and it's going to point to something called temp file. I could name it anything I want. Now, why am I using a macro variable? Because sometimes I might want to say, well, you know what? I'm going to keep this temporary file, and I might want to name it later on. And I might want to say something like linear regression Joe, or whatever I want to name this thing. And then if I rerun this, then my temporary file will get saved to a disk. So all I have to do is make the change in one place, and everywhere he sees this guy, he's going to fill this guy in right here. Now, some of you guys, this is confusing you. I know that. If that is confusing you, don't use the macro variables. I'm trying to keep giving a little bit of value add to people who are really good SAS programmers. If you don't know how to use a macro variable, then just type in the variable, the file by hand. You can do that just as easily. But I'm trying to show this at several different levels for people who might be more advanced programmers. So, okay, here I am. I'm going to copy this again and run it. And now I'm printing the first 3 of these guys off. So the first thing I'm going to do is I'm going to say, well, how about, as long as I'm making a copy of this thing, how about if we get rid of some of the variables we don't want to mess around with? Well, we don't want to use the variable index right now. So let's get rid of that guy. So as we build our model, we don't want to accidentally put index into the model. Index is the number of the record. So this is record number 2. And you can see that this guy right here is, this is not something I want to predict. I'm trying to predict who's going to crash their car. No, I'm sorry. This is a prediction of who's going to default on a loan. So this is just person number 2. We don't want this index to go in the model. What we really want to use is the loan, the mortgage, the value of the home, the reason for the loan, the person's job. YOJ, that stands for years on job. Derogatories, that's how many times a person has defaulted, like didn't pay off a credit card. So derogatories are real bad. Delinquencies are, and this should be sitting out there in your, when you could download this in the data dictionary, but I'm just telling you. But delinquencies, this is just your late paying in your bills. CL age, that's credit line age. That's how many months you've had credit, like how many months you've had a credit card. Number of inquiries, this is how many times you went out and tried to get a credit card. People who are going out and looking for credit cards are usually running out of money. They're bad. CL no, this is credit line number. That's how many credit cards you got. You got a lot of credit cards, that usually means you're running out of money. And over here we have debt to income ratio. So that's basically you take your amount of income that's coming in. If I have $50 in debt, but I've got $100 in income, $50 divided by 100, that means 50%. My debt divided by income is 50%. If I've got only owe $25, but I make 100, my debt to income ratio is 25%. So the lower that number, the better you are. So anyways, the first thing I'm going to do is drop this variable, and let's do that and see what we get. Okay, so he's gone now. So now let's start building the model. Well, before we do that, you're going to have to do things like fix missing values. Okay, so how do I do that? Well, the first thing I would do is we could come over here, and I can just see if we have any missing values that we might want to fix. One way I do that is I run a proc means statement using SAS. You could do this a lot of different ways, but I'll show you. This is a quick and dirty way of doing it. And miss. This will just tell me the number of missing values that I have. And we might also want to do, let's say, a min, and or how about a mean and a median. And run Var Numeric. Now, the neat thing about numeric is this is going to give me every single numeric value. So let's take a quick look here. So you can see I've got some so he's now given me every numeric value that I have. So you can see that loan doesn't have any missing values, but all the other guys do. They all have some missing values. So if we want to do a logistic regression, we're going to have to fix these guys. Okay, what else do I need to do? Well, how can we fix them? We could fill them in. Probably you could use a decision trees. Or we've been talking about using decision trees. Probably the easiest thing to simply do is filling them in with the mean or the median value. So, well, what could we do? Let's try doing that real fast. Okay, so the first thing you're going to want to do is when you fix a missing value, you don't just want to say something like, if the mortgage is missing, then you could just do something as simple as this. What's the mortgage? 65. This is the, we'll fill it in with this value. Comment these guys out. So we could do something like this. Now, this is not the best way to build that, to do this, but we'll start off by this. So let's rerun this guy. And you can see we no longer have any missing values for the mortgage. We just filled them all in. If they were missing, then we filled them in. So that's one thing you could do. It's usually considered a best practice to do something like this. So I'll show you how to do what you should do in the real world. You should never fix this variable and use the same name. You should give him a new name. So I would do something like this. The imputed mortgage due is equal to the mortgage due. So I've created a new variable called the imputed guy. And then if he's missing, then we're going to fix him. So let's see what happens now. See, so we've got this mortgage due, still has missing values, but the imputed guy doesn't, because that's the guy we fixed. Now, why do you want to do this in a real-world situation? Well, the reason in the real world is you've probably pulled this variable out of a database somewhere. So everybody at your bank thinks mortgage has a very specific meaning. It's defined in the database, and everybody in the company knows it. Now, if you start monkeying around with this variable by fixing it, or if you got outliers and doing something with those, if you're monkeying around with this guy, you've just changed the definition, and everybody in the company thinks it's one thing, and you've just changed it. If you change it, you got to give it a new name. That's what you should do. You should never go monkeying around with variables and use the same name. If you're going to play around with it, give it a new name. So I've got a question on the chat window. Let's see what it says. Is there a shortcut like it to mean value, like imputing? You know what? No, not that I'm aware of, Zach. I think you just have to type. There's actually some ways you can do it with writing macros, but we're not going to do this right now because I feel like I've already lost half the class. I don't want to lose them anymore. So we're going to just, at this point, we're going to keep it simple. Okay, now another thing that I like to do is I like to create a flag variable. And what is the flag variable? Is sometimes if a variable is missing, that's highly predictive. So, for example, if I don't have a mortgage due amount, that might be very predictive. Why? Well, maybe I don't have any record of having a mortgage at the credit bureau. Well, if I don't have a record at the credit bureau, there's usually a reason for that. Like maybe I changed my identity or something like that. So you usually want to fix your missing values. Now, there's much better ways to fix missing values, but believe it or not, mean and median, even though they're really simple, are actually surprisingly good. Okay, these are good ways to do it. Just because something's simple doesn't mean it's bad. So now I have two variables here. I've got the variable I fixed, plus I also have this flag variable to say whether or not I fixed it or not. So you can see now 8% of these guys have been fixed. So, okay, so let's do this to a couple of them. Let's not do it to everything because we're going to be here all night. But let's say we do that. Debt to income ratio, that's probably going to be really predictive. So let's do the same thing again. So while I'm typing this thing in, does anybody have any questions? Have I lost people? Am I totally confusing people? What's going on? Somebody help me out and talk. I'm hearing total silence, and as an instructor, that's scary.
Makes sense to me so far.
Does everything make sense?
Yes.
Does anybody else have any questions?
No, not so far.
Okay.
Somebody typed a question in the chat that you didn't answer yet. The question is, Don, for the insurance bonus, how does the data step for the amount model intertwine with the data step for the flag model? Is there a shortcut mean value? Oh no, that was you already addressed that one. Okay.
Okay. So here's the question. The question is, if you want to do, here's what I would do. I would build two specific models for the amount. So I would first do a variable for did the guy crash his car, and just build a simple data set, and I would have an Excel file that has index, person number 3 has a 50% chance of crashing his car. Person number 11 has a 42% chance of crashing his car. Just do that. Submit that to Kaggle and you're good. Now, build another model and only use people who did crash their car. In other words, you don't care about whether or not if the guy didn't crash his car, don't use him. Find everybody who's had damages of $1 or more and build a model for those people. And so then you figure out if a person does crash his car, what's it going to cost you? Build a data set with that. Then score the entire test data set. Okay, so you've got the data step, and the data step is going to tell you if a person does crash his car, what's it going to cost you. Okay, so now you have person number 3 has a 50% chance of crashing his car, and then you run it through the next model, and you say, oh, person 3, if he does crash his car, it's going to cost me $10,000. So that's what you predict if he crashes his car. So then you're going to put that one in Excel. So you're going to have really an Excel file or a row of the index, person number 3. Then you're going to have another column that has 50% chance. Joe has a 50% chance of crashing his car, and then you say, oh, and if he does, it costs me $10,000. So that's the next line. So it'll look something like this. Taking a little longer than I had hoped. Okay, so you would say index, that's the person's number. Then you would have a probability value, and then you'd have damages. So you're going to build a model for this guy. So this would be like 3, 11. I don't know what the test, Okay, so then you're going to build your first model, and this is going to be, 0.3, 0.2, 0.5, 0.8. Okay, then you've got another model, and the second model, you've built it only on people who did crash their car. So then you're going to have these big numbers, and you're going to have numbers like this guy's got a Maserati. So he's got the kind of car the guy drives, like a sports car, that's going to be predictive of damages. So let's say $10,000. And this person might have a little, Volkswagen. It's only worth $5,000. And this guy's got a old jalopy worth $50. And this guy's got like a car that's worth, I don't know, $15,000. So then the thing you're going to submit to Kaggle would be, for the second one, is going to be this thing times the damages. So you would submit this guy to Kaggle, and you would submit this guy to Kaggle. Because this guy has a 30% chance of costing you $10,000. Well, that means that his expected risk is $3,000. This guy has a 20% chance of costing you $5,000. So your risk is $1,000. This guy's got a 50% chance of costing you $50. That's a $25 risk. So that's how you would do this. And so you would submit just this, these two columns, whoops, and then you would submit this column and this column for the other one. Does that make sense, or did I lose you?
So just to clarify, for the amount damage bingo bonus, you only need to submit, like in this case, columns A and D only, not column B along with it.
No, Kaggle will yell at you.
Okay, got it. Thank you.
Kaggle only wants the number and the damages. Does that make sense?
Thank you.
Okay, so let's go back here. So I've got this debt to income ratio, and I'm going to impute it. Let's also, while we're at it, let's show you what happens, what we can do to figure out categorical variables. So proc freq data equals temp file table character. I think it's character. I hope no, it doesn't look like it. What the heck is the variables for the characters? Oh, I can't remember the max. Oh well. We're gonna do this old school.
It's underscore character underscore.
Underscore character underscore?
Yep.
Didn't I do that? I didn't know. I thought it should turn it blue. Let's find out. Oh, it worked. What do you know? Okay. So you can see I've got some missing values for job, and I've got some missing values for the reason that the person has a loan. Okay, so let's fix both of those guys. We could do this a couple of different ways. Let's fix years on job also. Let's do that. Just so I have three variables. And we will say this is not being fixed. Years on job. Years on job. And years on job, what's the average? We'll call it 7 years. So if I don't know how long you've worked at your job, 7 years. Now, in the meantime, let's do one other thing. Let's fix reason. And we'll just say if reason, if missing, reason. This one we won't create a flag. We'll say if we'll do reason, and what's the other one is job, right? So I'll show you two things you can do to fix a categorical variable. Okay, so we could just say if your job is missing, then we're going to fill it in with, what's the most common one? Other. Okay. So if I don't know what your job is, I'm going to say it's other.
Don, don't you want to change imp job to equal to job?
Oh, yes. That was a test. And you passed it. Good job. Oh, I just made a joke there. Good job. Never mind. I guess everyone's on mute because no one's laughing at my jokes.
All in the background.
Okay. See, it's funny is if I could tell anybody had laughed at my joke, they probably would have gotten some bingo bonus points. Anyways, we could also, you could create something like if the guy's reason for not having a loan, we could just say no reason. In other words, I could do something like this. What the heck? Where's my do we have an error or something? What's going on here? If missing, oh, I see. Then imputed job equals. If missing, then imputed reason equals. There we go. Let's try it now.
No, you should be looking for if job missing, not if imputed job missing. And the same for reason. Somebody else pointed that out, but it wasn't completely fixed. So if missing job, then imp underscore job equals other.
No, because I copied job into here.
Oh, okay.
So then if it's, so this is making an exact copy of it, and then I'm saying,
Okay.
oh, by the way, if it's missing, then I'm going to fix it. And I make a copy of reason, and if it's in there. So let's try this again. So there they are, none, and otherwise we're going to make it other. Okay, so let's start building a model. So the first thing we're going to want to do is proc logistic data equals temp file model. What's our target? Target is target flag. And that's going to equal what? The mortgage amount. And then the flag. So in other words, here's the mortgage amount, and this is did we fix it? Then we're going to use the debt to income ratio. And then did we fix it? And years on job, or years on job. Did we fix it? And we'll also do the imputed job and the imputed reason. And let's do a stepwise selection. And we also have to tell them that some of these guys are class variables. Now, let me do one other thing. I forget the syntax, so I'm going to have to go back and look. Just a moment. This is from some of the previous sync sessions. Maybe I got it in here. Aha. There we go. Plots only, Roc ID equals prob. And I see a chat message. What's the chat question?
Don, this is Lee. Can you hear me?
I can.
It's Zachary Reichenbach-Carr. He says, Don, is the M value to flag the imputation a way to make sure the model isn't too dependent on a bunch of imputed values? What is the reason for the flag?
Oh, okay. I was going to tell you that, and then I got distracted. Sometimes a variable, let's say I don't know your debt to income ratio, okay? And so I don't know what it is, so I just fill it in with the average, okay? Now, that's fine. However, it was missing, and I fixed it, but it was missing. Now, if it's missing, sometimes the fact that it's missing is highly predictive. So what I'm doing is I'm saying, okay, it was missing, and I fixed it to be an average value so that we can just move along, and I can use it. Because if it's missing, Stats is going to toss it out. So I got to fill in a value there. But also, the fact that it was missing could predict very well if a person's going to default on a loan. Because if I don't know your debt to income ratio, for example, it might tell me, that may mean that you don't have a record at the credit bureau. So let's say that I don't know, I call up FICO and I say, hey, what's the deal here? I'm looking for Zachary and can you tell me about his credit history? And they say, well, Zachary doesn't have a debt to income ratio, and he doesn't have a years on job, and he doesn't have a number of credit lines. He doesn't have anything. And I'll say, okay, I'm going to fill them all in with the average. But isn't it kind of creepy that there's absolutely no history of Zachary in this world? Probably he doesn't really exist. So what happens is these missing values become flags that go into the model that's like, hey, well, we filled in all the average values, and Zachary would just look like an average person. But he's not. He doesn't really exist because all these flags are set to 1, and the model's going to jump out there and go, aha, yeah, Zachary's all average, but by the way, all of his flags are set to 1, and those numbers are going to be really high because it's going to predict that Zachary is like a fraudulent person. Does that make sense?
Don, this is Lee Timms once again.
Okay.
That totally makes sense, but where in the output do we see those implications?
Well, we're going to see that in a moment when we get the output.
Cool.
Okay, so I'm running this proc logistic, and here we go. So here's our proc logistic, and we did a stepwise selection here. Okay, so what happened was here's our winning guy. So first of all, the first thing somebody asks is, how do I know if my model is any good or not? Well, one thing I always do is when you run your proc logistic, and I'm going to post this code, so don't worry, put this command right here. And then when you do your very bottom here, do roc at 0.1. And so every 0.1 value, he's going to draw a point. If you do this like at 0.05, the curve will be even more and more round. But okay, you can see here, this is your Roc curve. Now, this is a really good Roc curve compared to an average. This is pulling names out of a hat. This is the Roc curve. And I hope you guys have been doing the reading for the class, and you could know what a Roc curve is. A perfect Roc curve would be a straight line all the way up and all the way across. That's perfect. The only thing that can get that perfect is a magic 8-ball, okay? Those are the things that are most accurate things in the world. Other than that, you're going to have, and perfectly rolling dice is this thing here. Magic 8-ball, Google it, it's funny, okay? Anyways, so you can also look at things like, if you're going to compare several different models, you could look at the, I don't know, there should be somewhere around here, your AIC values and stuff. But really, I'll tell you the best way to know if your model's any good is just look at your Roc curve. Now, somebody asked, how do we know if this thing is predictive or not? Well, you look at the coefficients, okay? So you can see here that this guy here, mortgage due, has a very big number associated with it, 0.4882, okay? That's a number greater than 1. It means that a person who doesn't have a mortgage is more likely to default on a loan. Debt to income ratio. A person who doesn't have a debt to income ratio at the credit bureau is a person who's more likely to default on a loan. It's highly predictive. Years on job, if you don't have that, it seems to be less likely. But I would probably argue that I would take something like that out of the model just because I don't want to reward a person for, this is a practical thing, is I would say that the years on job seems to reward you for not providing that information. So even though the model, even though the mathematics says, well, people who don't tell me how many their years on jobs, those people tend to be less likely to default on a loan. In a real world situation, I wouldn't use that variable because that doesn't make sense. It's like then the guy wants a loan, and then you say, well, you didn't get the loan, and then he says, okay, well, I lied. I'm not going to tell you how many years on jobs. So he withholds information, and then suddenly he gets a better score. I don't want to reward him for that. Does that make sense to anybody, or am I rambling?
No, that really makes sense, and thanks for the explanation. It helps to interpret those M values. Okay, so then the next thing that we're going to do is we would create a program to score new people. So, data, new, and then we would just say, set in file, run, and this would be our scored data set here.
Don, quick question.
Yeah. Yes, sir.
When you're looking at a model like that, is there an easy way to tell really that you're overfitting?
The best way to know if you're overfitting is if you start looking at this Roc curve. The single best way to know if you're overfitting is to have a holdout sample and see how your holdout sample works. But go look at, let's see if I can pull this up. One of these guys, let me see where it is, for the class shell. Well, I'll worry about that in a sec. In some of the notes I show you how to interpret a Roc curve. Has anybody seen the PowerPoint notes that I posted?
Yes.
On that? Let me see if I can
Yes,
find it.
I have.
Okay. So, Just give me a second. Just a sec. I think I have a whole bunch of PowerPoints, and if you want to look at nothing more than Roc Curves, where the heck is it? No. I thought I had somewhere where I'm showing you Roc Curves and how to interpret.
Yeah, it's a PDF file, and the one that's like too bowed or too perfect is probably got wrong information. The one that looks like the diagonal line is useless. Yeah.
Got it. Here it is. Okay. So let me just do this really quick. Zoom. Let's make this 100. Okay. So in one of the things I post, okay, this is like a good model. Okay. This is too perfect. When you get something like this, it's too good to be true. It probably is. You gotta be careful. If you get something like this where it starts going through, that's an overfit model. So when you start crossing over, and this is a bad model, but if you start crossing in and out, that's a good sign. It's not the only way, but if you got something like this, look at the Roc curve, and if you start going in and out of this guy, that usually means you've overfit. But the best way to do it is to see how you perform on new data that you've never seen before. So in other words, have a holdout sample and see how your model did on it.
Don, regarding the holdout sample?
Yes?
Would you have, for this Heloc, would you have separated the data and had a training set and a test set?
Yeah, you can do that. You could
I've been
definitely
doing that for each of my models. So I don't know. It wasn't demonstrated for the last one, so I wasn't sure.
No, I didn't do it in this, but I was just building a model. Given the lack of time, I didn't walk down that path. But yeah, you can definitely split this thing into two data sets. So you could do something like this, if ran, holdout. And then you could, so you're going to create two data sets. If, heck, let's just do it this way. I think this, I'll show you the way Professor Body, I think, shows you guys how to do it. Train flag. So then you would have this guy right here, this training flag, and if this random number is greater than, this random number will give you a number between 0 and 1. So if it's greater than 0.2, then it's going to be training. And then you would only and you would do something like this. There, and then you would do something like this. You would build a model, and just for fun, let's only use the debt to income ratio here because we're running out of time. Okay, so there's our model right there. So I would build this model, and I would do something like this. To build my scoring data set, I would do this. So, and then I would say log odds equals what? We're running out of time. I'll try to get this fast. Is equal to this. Plus this guy times the imputed debt to income ratio plus this guy. Odds is equal to log odds, or exponent, I think that'll work. So now I've got two data sets. One is if the train flag is equal to, okay, so here we go. So I can print and we'll print the index and the prob. And by the way, we also know what really happened, so we may as well print that one as well.
Should the scored data be the test data set?
What, this one here?
Yes.
Wait, something happened. Index. Oh, wait a minute. Index. Let me get index back here. Okay, what was your question again?
Data set. Should we be using the test data set?
Well, yes, we will eventually use the test, but the first thing I do is I want to make sure it works. So, whoops. Okay, so the first thing I would do is before I do the test, I'm going to do the train. I'm going to make sure it works. Okay, it seems to work. This guy says he has a probability of 61%. He gets a 1. This guy's got 61%, 1. So, anyways, let's try this with the test set now. Now you see that this is what this guy. Now everybody would say, why did you get the same answer over and over again? Well, because I had a lot of missing values, and if you remember, I fixed the debt to income ratio with the average, and then I've got that flag. So I've only had two variables in the model, so that's why I'm constantly getting these answers that I am. If I used more variables, that wouldn't be happening. Did I totally confuse everybody?
Not everybody.
Oh, okay. So with this information, you could probably go out there and follow the instructions that I gave you for the class for this guy right here, and you can create your own Roc curves just by following these instructions using this little guy right here. This little Excel file. So I recommend taking week 5 and just reading this stuff. I just walk through step by step by step on how to do this. Hearing nothing over there. Anybody, did I lose everybody, or are you sort of following along?
So I do have a question on this gains lift.
Okay, so fair enough.
So the input into the gains lift on your for your code that you had posted was 2 columns. One was the actual and one was the calculated target. So
right.
in that case, for building the gains model, is that using the holdout set, or is that using the whole training training sample, or does it not matter?
In order to do this, in order to build the gains chart, you would need to know 2 things: the probability, which your model calculates, and you need to know what really happened.
Correct. So those 2 columns, I got that part. But is that
you could build a Roc curve using this guy because he was the input file, but I broke out a little training set. And this guy was also the input file, but I created a test set, but I knew the answer.
Sure.
Okay, but you're asking, could you use the holdouts, the real test set where you don't know the answer?
No, not the real test, not the real one, because where we don't know the answer. I'm talking, so we build the model. Let's say I don't do a training and a test set or a holdout set. Sorry, holdout set, not test set. So if I build the model using the whole training sample and then generate the results for the 2 columns based on the whole training sample, would that be valid? Or is that more appropriate to have the training built on the partial training?
In a real world situation, you would probably have a holdout sample. Although in this case, you don't have to have a holdout sample. In a real world situation, you probably would want to do that. Not even probably, you would definitely want to do that.
Okay, then
we're not even walking down that path in this class. You sort of covered it last class. Some students still remember how to do that, and I like it when they do it. However, at this point, I'm more focusing on how to build a model, like looking at the fixing the missing values and doing things like looking for outliers and things like that. That's what I want you to learn. Having a holdout sample is great, and it's great, and you will have to use it in many industries. This class, I am not forcing you, although if you tell me you did it, I usually will give you some bonus points.
Okay, then I must be doing something wrong, because I think what was happening for me when I was trying to calculate the gains was it did divide it into 10 quantiles, so to speak, or 10 groups, but the calculation for one of the columns was coming out to be empty completely. But I can send you an email on that part on what I'm seeing.
Just show me what you're talking about, because I'm not certain what's going on. So you'd have to show me.
Let me see if I can pull that code up.
Well, we got to go. We got the next classes coming in, so you can if you send it to me, I'll take a look and get back to you on that.
Yep, sounds good. Thank you.
Okay.
Don, are you going to post this recording and the code?
You got it. Definitely will. And I'll do it either later tonight or early tomorrow for you.
Thank you.
Okay. So let me get out of here. Does anybody have any final questions before we move on to the show and tell section? Why create that flag variable for imputations? Was for a long time ago, right?
I have
Okay.
one
Yeah,
question.
Don, that was part of the other question regarding the M values.
Okay. Any other questions?
Without having read the gains piece, just a quick question. In the linear regression, when we did the training and test, we compared like a mean average error, right? Y minus
Right.
Y hat. Over here, we have 0 and 1s, and then we are calculating probabilities. So is that gains thing for us to be able to compare the test and training set performance?
You could do that. Another thing that you could do is you could come up with you could assign, let's say, a probability score of anything greater than, say, 0.5, and say that that's 1, and anybody with a probability of less is a 0, and maybe do a confusion matrix of I predicted a 1 and the real answer was 1. I was correct. I predicted a 1 and the real answer was 0, so it's not correct. So you could do something like that. There's several ways you can do this.
Okay.
So,
okay,
anyways,
thank you.
Okay, any other questions before we dive into the next section? Okay, if anyone has any follow-up questions, send me an email or call me up tomorrow. You know, you can just, you guys all have my number and call me up, and some of you have called me already. Has anyone who's called me on the phone, have I yelled at you?
Nope, you were wonderful.
I don't know who you are, but I'm giving you bonus points.
This is Lee Timms. I'll take them.
I'm not really giving you bonus points for that, Lee. But I do like flattery. Okay, but seriously, people, I've never yelled at anybody for calling me, so please call me with questions. Because believe me, whatever question you think you have and you're like, I'm totally lost and I'm the only one who doesn't know, no, everybody, if you're lost, everybody else in the class is lost. You got to call me. So anyways, I'm going to leave. No, I'm going to stop the recording and then start it up again so that there's two different recordings here.